Okay, so this is the question number 16 on AMC 10B 2022. Okay, so it's a nice geometry problem. So we are given a rectangle with the sides 4 to 8. So let's go ahead and write those first. Okay, this is 4, and this is 8, and this is 4 as well. And then there's a square with the side is 5. So let's actually write those as well. Okay, as soon as I see right here a rectangle, since this is given 90 degrees, and that means this is going to be parallel to this guy, which makes this is also 90 degrees, but just keep that in mind. So that will be 4, okay? So, and questions asking the shaded region. So there are a couple of ways to try this one, but I'm going to use the similar triangles, but I'm going to show you one other approach that I want you to try. So if you connect these two, then you had two triangles, and then maybe the larger one is easier to find, but the smaller one is you can try. So which is going to be a bit tedious for some people, but you can find those two and then add them together, which is one way to do this problem. But I'm going to draw another way, okay? So what I'm going to do, I'm going to find the area of the, like this rectangle, and subtract those three smaller triangles to get the shaded region, okay? But as soon as I see some 90 degrees or parallel lines, which is like squares and rectangles has parallel sides, I do need to hunt for similar triangles, okay? Which is gonna help a lot. So, but I don't really see another like angles that maybe we can use it. Like if I can use like side, side, side angle, I mean, the triangle similarity, but I don't have three sides either. So which is why I need to chase some angles, okay? But before we do, this is 4, this is 5. So if we use the Pythagorean triples, 3, 4, 5, that's just 3. That's something. But I'm gonna go ahead and label this guy as alpha and this guy as beta. So, these two angles is actually add up to 90 degrees because this is 90 and the other two add up to 90 as well. And we do know this is a square, so which makes these guys as 90 degrees. Since this is a straight line, so this has to be 180, 90 is right here. So this guy and this guy should be add up to 90. That means this is also beta. And since this is 90, then this is gonna be alpha. And since this is 90, then this is gonna be beta. And this guy right here is gonna be alpha. So I'm gonna draw this a bit bigger so you can actually see. So let's try right there. Okay, so what I have, maybe I should label those so we can kind of see. I'm gonna call A, B, C, D. Okay, so let's K, this is K, so this is T, A, K. So this is beta, and this is alpha. So we know now this triangle, which is actually the small triangle, and this triangle have the same angles, which means they are similar. So then we can write the ratio of the similarity, right? And some people may say, okay, we have this is 5, and then that means this 2 has to be 3, 4, like the legs. You could say that, but before we I should be like saying this this triangle right here and this triangle right here has the same hypotenuse, and then we know they were similar. So since they have the same hypotenuse, they are not just similar, they are congruent. So then we can say the legs are 3 and 4, right? So the alpha is opposite to 4, so alpha is opposite to this side, so that's 4, so that means this is 3, which makes this a K1 because this leg, I mean this width, which is the DC, and that one is 4, that's the same as AB, so which is why this is gonna be 1. Okay, so if this is 1, and we know this small triangle with the other two were similar, the lengths were 3, 4, like ratio, but this is like 1, which is opposite to alpha, right? And if I want to make the similar ratio with the other ones, like alpha is opposite to 4, so that's like kind of 4 times something. So I can write this guy as 4/4. That will make the other leg as 3/4, and this guy will be 5/4. Again, this is just the Pythagorean triple 3, 4, 5. You just multiply 3, 4, 5 by 1/4 to get the legs because we know they are all similar. So now we know the all these sides, we can just find the shaded region. So that should be DC is 4 and BC is 7 minus area of this triangle. Okay, area of this triangle is 4 times 3/2. And then I have the same thing right here. So I can multiply this by 2. And then I have this smaller triangle, which is 3/4 and 1. So 3/4 times 1/2. And if you subtract those, you will get 15 and 5/8, okay? And that is your answer. So as you see, we just used the Pythagorean, I guess, triple and the similar triangles. So the similarity is I guess, the big point right here, because everyone knows about the Pythagorean, maybe Pythagorean triple as well. But the similarity is helpful in a lot of different cases, okay? Now we just use in this problem as well. So for number 16, it's I guess straightforward as long as you are good with the similar triangles.